In November of 2015, I had a chance to go and visit the Biosphere II in Oracle, Arizona, which is north of Tucson and southeast of Gilbert, where I was visiting for a wedding of a friend. The structure was built in the late 1980s and finished in 1991, and it cost around $200 million to build. From your readings, you'll learn more about the circumstances of the human missions and what happened during the time they were inside. Just a little clarity, though, on the name. It is called Biosphere II, not because there's another Biosphere glass dome thing, but because our Earth is supposed to be Biosphere 1, and this man-made structure was built to try and replicate it on a smaller scale. The Biospherians, as they were called, entered in through this sealed door lock, much like astronauts entering the space shuttle. Although much of the original space for agriculture has been converted for other uses, there are still a few plants left over, including banana trees, coffee trees, and lemon trees. We first entered into the tropical rainforest, which is meant to simulate rainforests in the Amazon with a canopy and undergrowth. As you can see, it was very humid and hot inside. One thing I found interesting is that along with insects and other small animals, a primate known as a bush baby was also included as part of this habitat at the beginning of the human missions. Next, we turned around and entered into the ocean ecosystem. It's 100 meters long and originally included many different types of fish and corals. There's a few fish still left in the tank, but there's a constant battle against algal growth in the ocean. There are waves being artificially produced by a machine at the far side of the ocean. Here's a shot of our fearless tour guide who was very generous and answered all my weird questions like who cleans the glass and what was security like during the human missions. Next, we walk through the grasslands and past the mangrove forest and into the desert ecosystem. Interestingly enough, this desert is modeled after the deserts in Baja California and not the Sonoran Desert where the Biosphere II is located. The glass makes this area very hot, even in November when I was visiting. So these vents actually bring in cooler air to keep the temperature from getting too hot for the plants inside. After visiting all the ecosystems, we got a chance to go into the belly of this beast, affectionately known as the technosphere. It is an engineering feat to control temperature and precipitation patterns in all these different ecosystems, and to recycle the water that condensates on the glass or falls as rain through sprinkler systems. Climate had to be controlled as well in each ecosystem and also in the human habitation. We got to walk into one of the lungs, which serves as a release when the air pressure builds up inside of the sealed structure. If they didn't have these release points, then the air pressure would break the seal. A 20,000-pound weight sits on top of this flexible but very strong rubber and will lift up when pressure is high inside the biosphere. And then actually the weight of the thing sitting on top of this structure will push the air back out into the biosphere when the pressure subsides. There is also a viewing area for the ocean habitat that is a bit underwhelming because there are just a few tropical fish and not much else to see. They are planning on renovating this ocean area and adding an island to make it reflect the ocean habitats in the Gulf of California off the east coast of the Baja Peninsula. The white section of this structure is the human habitation, which included a large kitchen and living quarters for the Biospherians. In the original mission, every 8 days a different member was expected to cook all the meals for everyone. But as you'll learn in the readings, their calorie count was quite low and it didn't seem like they were deriving enough energy from their meals. They originally had quite a large area for growing food, which has now been converted to something called the Landscape Evolution Observatory, or LEO, which the University of Arizona is using to test how plants will grow under different climate change scenarios. I really enjoyed my visit, and I hope that if you're in Arizona or if you visit Arizona, that you get a chance to see this in person because I think it's really, really cool. I hope you enjoy the readings this week, and I will talk to you guys soon.